We're going to be looking at the differences between chillers, AHUs and RTUs. Coming up, how to recognize each of the units, the basics of how each unit works, the differences between each unit, and where to locate them. Before we jump into the content of today's video, I just want to take a moment to thank our partners over at Danfoss for sponsoring this video. Since we're discussing air conditioning systems, it's worth mentioning that Danfoss have solutions that can help you increase efficiency and bring your system in line with refrigerant regulations across all types. Danfoss have a deep understanding of chillers, air handling units and rooftop units, and they have a broad portfolio of parts to help you enhance performance and reduce your energy costs. Find out more about their air conditioning solutions at airconditioning.danfoss.com. So first of all, let's take a look at chillers. Chillers are used to generate chilled or cold water which is pumped around the building to provide air conditioning by collecting unwanted heat. There are two main types of chillers, which are air-cooled or water-cooled. The term water or air-cooled just tells the engineer how the chiller's condenser is rejecting heat from the building. But don't worry, we're going to cover how both these work in just a moment. Water-cooled chillers are typically located in the basement or the lowest floor of a building. This type of chiller needs a cooling tower to reject the heat from the building. The chiller produces chilled water and pushes this around the building to air handling units and fan cool units. These units circulate the air around the local space as well as the building. The air is then forced across the heat exchangers containing the chilled water, which extracts the unwanted heat before the air is distributed throughout the building. The unwanted heat that is extracted from the air collects in the chilled water loop, which is pumped back to the chiller where it will transfer over to the chiller's condenser via a refrigerant loop. The condenser absorbs this heat and then dumps this into the condenser water loop, and this runs between the chiller's condenser and the cooling tower up on the roof. The cooling tower will force ambient air across the condenser water to extract the unwanted heat and reject this heat out of the building and into the atmosphere. So in this instance, the condenser of the chiller has been cooled by water, so it is now a water-cooled chiller. Water-cooled chillers are typically used on large commercial properties with high cooling loads. You can tell if a building has a water-cooled chiller because it will need a cooling tower, which is typically located on the roof. There will usually be more than one chiller and cooling tower, and it's not uncommon to have at least 2 or 3, even more, just for redundancy as well as variations in cooling demand. Now, we've covered this system in great detail previously in other videos. There's some links on the screen now, or if you want to learn more, you can see the description below. Air-cooled chillers. Air-cooled chillers are typically located on the roof of the building or outside, say in the car park. The air-cooled chillers also generate chilled water, which is pumped around the building to air handling units as well as fan cool units, etc., in order to cool the building and pick up unwanted heat. The air is forced to circulate around the building and local space and will pass across heat exchangers within the air handlers and fan cool units. This unwanted heat is again transferred over to the condenser of the chiller from the evaporator. It is transferred via a refrigerant which loops between the evaporator and the condenser and is forced by the compressor. The difference with this type of chiller is that the fan blows air across the condenser, which removes the unwanted heat. So in this instance, the condenser of the chiller has been cooled by air, therefore it is an air-cooled chiller. Air-cooled chillers are typically located outside because they need access to a lot of ambient air in order to reject the heat. This type of chiller can usually be found on medium to large commercial property, and there's an example on screen now of how these units look in the real world on the roof of an office. Again, we've covered this in great detail in previous videos. There's a link on screen now for that, or see the video description below to learn more. AHUs and RTUs, air handling units and rooftop units. Now these two systems both serve a very similar purpose, and they can even look fairly alike. Both of these are used to distribute air around the building and will contain fans to achieve this. They will both take in fresh ambient air and clean this through a filter before heating or cooling the air to suit the demands within the building. The main difference between these two is how the air is heated or cooled, and we'll look at each of these to learn the basics of how they work in just a moment. Air handling units are also referred to as AHUs for short. AHUs are typically located inside the building, although you can find these in the rooftop plant rooms, and it's becoming more common to find these more robust, weather-tight AHUs sitting out in the open on the roof to free up space within the building. Their purpose is to distribute air around defined areas within the building. Sometimes one AHU will supply the whole building, but it's common in newer buildings to have multiple smaller AHUs feeding different parts to provide a better indoor environment, as well as resulting in energy savings. AHUs typically do not have their own cooling system built in. Instead, they will be connected to a central plant, water or air-cooled chiller. Occasionally, they will use some sort of split AC unit, and you can also find these connected to district cooling networks. AHUs are connected to ductwork, which provides a defined route for the air to travel around the building. In a simple form, an AHU will use a fan to suck in fresh ambient outside air, which will then pass through some filters to remove any dust and dirt. It will then pass through the cooling and heating coil heat exchangers, which, as discussed, are typically fed from central plant units. Once the air has passed over these coils, it will be pushed out around the building. Another set of ductwork will be collecting the warm used air from these rooms and will bring this back to the AHU via another fan. This fan will then eject the air from the AHU and the building. Now, there are many different setups for this, and again, we've covered this in detail in previous videos. There's a link on screen now where you can watch that or see the video description below. RTUs, rooftop units. These units are always located on the roof, as the name suggests. They are very common in shops and small commercial properties and are popular because they are simple, compact, self-contained, all-in-one HVAC units. Their purpose is to distribute conditioned air around defined areas within a building. RTUs are also connected to ductwork, which provides a defined route for the conditioned air to travel along. RTUs typically have their own inbuilt refrigeration system to provide cooling only, but they can also contain a heat source such as a gas-fired heater or an all-electric heat pump. RTUs house all the components within the rooftop unit. This contains a number of dampers to control the flow of air and can allow air recirculation if conditions are right. The unit will also contain filters to clean the air, as well as heating and cooling coils and at least one central fan. The refrigeration system is also connected to the back or the side of the unit, and this is used to control the temperature. The fresh ambient air is sucked in via the fan and passes across the dampers. It then passes through the filters to remove any dust and dirt before its temperature is adjusted in the heat exchanger. The fan then pushes this out into the building to condition the space. Another duct will collect the warm used air from the rooms and will distribute this back to the rooftop unit, where it will be ejected or recirculated if that option is available and the conditions are right. Okay guys, that's it for this video, but before I close this out, I just want to say another special thanks to our sponsor Danfoss one last time. Don't forget to check out their broad portfolio of air conditioning parts and solutions by heading over to airconditioning.danfoss.com. Don't forget to hit the like, subscribe and share button if you've enjoyed this video and it has helped you. You can also follow us on Facebook, Instagram, Twitter, and don't forget to check out our website, theengineeringmindset.com. Once again, thanks for watching.